The foundation of secure subscriptions starts with precise store configuration. You must define identical product identifiers in both the Apple Developer Program and the Google Play console. For iOS, configure the subscription group, the specific product identifier, pricing tiers, and the duration within App Store Connect. Crucially, enable the entitlement com.apple.developer.in app purchase in your Xcode project capabilities. On the Android side, define the base plan and all associated offer details, specifying the billing period and the renewal type in the Google Play console. Maintaining consistency in these product IDs across platforms is essential for simplifying your back-end entitlement mapping logic. The product ID serves as the primary key the client uses to initiate the purchase request. Before displaying any purchase button, the client application must fetch current product metadata. On iOS, use the skProducts request class to query Apple's servers using your defined set of product identifiers. The successful response returns skProduct objects, which contain the necessary localized price strings and descriptions, ensuring display compliance with store rules. For Android, utilize the billing client, query product details method to retrieve product details objects. These objects are complex, containing pricing phases and offer tags required to accurately present the correct purchase options to the user. Always cache these retrieved product details locally to minimize network latency and guarantee availability, even if the device experiences temporary network disconnection. To initiate a purchase on iOS, instantiate an skPayment object using the fetched product details and immediately add it to the skPayment queue using skPayment queue, default.add payment. Your application must implement the skPayment Transaction Observer protocol to correctly handle all transaction state changes, including the critical states of purchasing, purchased, and failed. On Android, launch the billing flow using Billing Client. Launch billing flow, passing the necessary billing flow params. The transaction result is handled asynchronously via the Purchases Updated Listener interface. A successful transaction on either platform yields a receipt for iOS or a purchase token for Android, which must be immediately and securely forwarded to your back-end server for definitive validation. Client-side receipt validation is fundamentally insecure because the client environment is easily compromised through jailbreaking or rooting, allowing malicious users to forge purchase receipts. The back-end server must function as the sole authority for determining user entitlement status. Implementing this server-side validation process is the only way to prevent unauthorized access to premium content. The server requires platform-specific credentials to communicate with the stores. For Apple, this is the shared secret used with the App Store Server API. For Google Play, you need a service account key configured with the View Financial Data permission for the Google Play Developer API. The server validates an iOS receipt by constructing a POST request containing the base 64 encoded receipt data and your shared secret. This request is sent to Apple's verification endpoint. Use the production URL https://by.itunes.apple.com/verifyreceipt for live transactions, and the sandbox URL https://sandbox.itunes.apple.com/verifyreceipt, strictly for testing. The server must pass the JSON response and check the status code. A status code of 0 indicates a valid receipt. Status code 21007 specifically signifies that a production receipt was mistakenly sent to the sandbox environment, requiring the server to immediately retry the request against the production URL. The response payload includes the latest receipt info array, which contains the current subscription status and the definitive expiration date. Android purchase validation relies entirely on the Google Play Developer API. Your server uses the service account credentials to authorize all API calls. To verify a subscription, call the Purchases subscriptions.getEndpoint. You must pass the application package name, the subscription identifier, and the unique purchase token. The API response provides the current subscription state, including the expiry time millis timestamp and the auto-renewing status flag. The server must confirm that the purchase state field is 0, meaning purchased, and that the consumption state is also 0, meaning unconsumed, specifically for non-consumable subscriptions. The purchase token must be stored securely in your database because it is required for all future status checks and renewal monitoring. The server database schema must securely store all critical entitlement data, linking it directly to the user identifier. Essential fields include the platform identifier, either iOS or Android, the specific subscription product identifier, the definitive expiration timestamp, and the unique transaction identifier. For iOS, store the original transaction identifier to accurately track the subscription lifecycle across all renewals and upgrades. For Android, the purchase token must be stored. This unique token is the key required for all subsequent API calls to check the subscription status. Implement database indexing specifically on the expiration timestamp field to efficiently query subscriptions that are nearing renewal or immediate expiration. Subscription status changes are best managed proactively using server-to-server notifications, eliminating inefficient polling. Implement listeners for Apple's App Store server notifications, known as ASSN, and Google's Real-Time Developer Notifications, RTDN. These notifications immediately inform your backend about critical events such as renewals, cancellations, and billing issues. When a renewal notification is successfully received, the server must update the stored expiration date in the database immediately. Conversely, if an expiration notification is received, the user's entitlement must be revoked without delay, restricting access to all premium features. This system ensures entitlement accuracy without relying on the client application. If a subscription payment fails, the subscription may enter a grace period, allowing the user continued access while the store attempts payment recovery. Google Play automatically provides a default grace period, and this status is reflected accurately in the RTDN payload. Apple's system handles billing retry internally, but the server must actively monitor for the did_fail_to_renew notification type. Implement specific logic to maintain entitlement access only during the defined grace period duration. If the payment recovery ultimately fails, the subscription transitions definitively to the expired state, and the server must strictly enforce the immediate entitlement revocation.